So now I'm just going to go over the GitHub repo so you can see how I set up my project electronically as the circuit as well as the code, and go over that code. So this is the capacitive touch lamp project that you can find on my GitHub. The link will be in the description of the video. And I write a pretty extensive README, and I'll include the link to the YouTube video when I'm finished recording. But basically I have this running on a Raspberry Pi 2, and I set up and I'm using the Adafruit Python MPR 121, which is the sensor I'm using, that library for the capacitive touch capability. And you're able to set up your Python environment through here, these commands. And the Arduino, you just need to upload this specific sketch, and I provide the path from the project repo. I set up a cron job using a launcher script similar to something else that I did within my Hue button project, in which I set up a cron job to run a launching script which will just change directories into the capacitive touch directory and then run the Python script needed as soon as I add power to the Pi. So as soon as it reboots, this script is running, and possibly within 60 seconds everything is ready to go. How the code is working is I'm using that Python script to run automatically thanks to the cron job, and it's sensing the touch from the capacitive sensor. Once it receives one, it'll spin off two threads. One will play the audio associated with a generated number, and another will send a serial communication to the Arduino, and the code on the Arduino will take that serial communication and play the lighting animation with specific timing to the length of the audio file. So what that means is when I touch the Empire logo, I will know that I need to play the Imperial March audio track and say that's 37 seconds long or something like that. I will send a serial communication to the Arduino to play the lighting animation specific to the Imperial March, as well as the lighting animation will be running for that 37 seconds. So the transitions between the audio and the lighting should be very precise. That's just through testing that I had to do extensively. For example, for ones that play multiple, so for the light side and dark side of the force, for example, I have maybe 10 audio clips for each of those. So I create a random generated number which will then pick which audio clip that I'm going to be playing based on your touch, which means they can play, more than one at a time, or not. They can play in a row the same clip because it's randomly generated, but you'll eventually cycle through all of them if you use the capacitive touch enough. So I wanted to get this effect so no matter when you touched it, you're getting something new, but you're also getting something random. So it's not just in a cycle that's predetermined. So you can touch the red lightsaber and get Vader breathing, and then you can get Vader shooting his TIE fighter blast, and then get Vader breathing again, and then get Vader breathing again, and then get Vader's lightsaber glow. So that's kind of how it'll work. We'll generate a random number when you touch it, play the audio cue associated to that random number, and then send a serial communication which will play the lighting animation associated to that audio file. So on the Raspberry Pi, I have the capacitive touch sense VIN going to the Pi 3.3 volt. The ground is connected, and the serial clock and data are also connected right here on these pins. For the Arduino, I just have the NeoPixel chipset with 5 volt going to the 5 volt on the NeoPixel, ground to ground, as well as pin 6 on the Arduino going to the data in on the NeoPixel. And as I say here, pins 0, 4, 5, 8, and 11 are the pins that I'm using on the capacitive touch sensor. That's just because that's where the wires were easily hooked up when I was organizing the physical space for the copper tape wires on the logos on the outside of the box. So if you go into this examples directory, you'll find cap.py, which is the main Python script running constantly. And we have two flags, and these flags are used to determine when each thread has completed. The first thread being these audio cues, and you can go through the audio folder. This has the 5 different folders for the 5 different logos, and it'll have each one their wave files to show you this is the dark side, so the red lightsaber, here's all the different things he can do, he can say. These are defined methods to play each of these audio files, and we have them organized by the logo. And then the second threads will be sending a serial communication to the Arduino file, and these are the lighting functions. So after you get past all of that, the content, this is the actual functionality, which is checking while a capacitive touch pin is touched. And this is where I define the pin that's being touched. So if pin 8 is touched, I know I'm touching the dark side. So that's the red lightsaber. So this is where we're going to be doing the random number generator right here. And I have 30 animations overall, so the dark side of the force has 13 specifically, so I randomly generate a number between 1 and 13, and I just check if it's a specific one, then I'm going to start the thread for the audio as well as the lighting animation associated to that. And then I have these organized by the dark side, the Empire's logo, the light side of the force, the blue lightsaber, the Star Wars logo, and the Rebel Alliance logo. And that's it for the Python. For the Arduino, if you come back out here, this is in the capacitive underscore touch underscore lamp folder right here. So when you touch this, you can see that I am setting up the NeoPixel ring to have 100% brightness as well as the serial communication. And when I'm reading a serial communication, I will take out this backtick. That is subtracting the ASCII value number from what I'm sending. So I am sending these serial communications, lowercase a through z, as well as curly bracket, open and close, pipe, and tilde. The ASCII values of these, I have 30 animations, so what I did is I subtracted this to make the switch case actually have 1 through 30. And the switch case will run and play the lighting animation, which has specific timing and colors, to that audio file. So if I'm sending A, that means that I am playing the first one right here. What is the bidding, my master? Something like that. And so I know to subtract this from A and say, I'm not exactly sure what it is, but let's say that lowercase a has an ASCII value of 97. This backtick has a 96 value in ASCII, so I'll subtract that, so I'm actually getting a value of 1, which I assigned to variable, and so that's why this lighting animation is played on case 1. So I guess I could have set up these cases to be 97 through whatever, but just to make it simpler to read the code, you can do something like that. So if you're confused on how I did that, that is how I approach the serial communication. And then these are just the different lighting functions. So this will play for that specific amount of time, whereas this one plays for like almost twice as long. So that was just trial and error going through and seeing how long the audio clips correlated to the lighting effects. So that's the code. So now I'm going to go back over the actual box so you can see a demo.